Next we'll be learning about Chebyshev filter now. In Butterworth filter, you also have two more different types. I'll just say you the overview, okay? They may give you this type of questions like now from normalized low pass, you have converted into our analog low pass, right? Next, they may give you low pass and say find high pass, band pass, and band stop. Normalized low pass to analog low pass also they can ask. So these four types also they can ask. For that, what you have to do exactly in the sense. So, okay, here this is high pass. Here you see they have given one normalized low pass filter function and they have given me omega p of it, and they have said find low pass filter with omega c is 10 radian per second, high pass filter with omega c, then band pass filter and band stop filter. Basically, when they give you questions like this, what you have to do is you have to make use of this table. This table gives us a lot of information, wherein the left part of the table gives us the information. Your low pass to high pass, low pass to band pass, and low pass to band stop. Using all these formulas, you can just convert them. For example, in this question they have given me low pass filter, right? First I'll find n. Okay, after finding the order, okay, you actually don't need to find n in this question because they have directly given you one low pass filter equation, right? The normalized low pass filter equation. This is actually the transfer function that they have given you. Basically, this is the transfer function. So you don't need to find n, omega c, and the normalized transfer function. You should directly find the transfer function of high pass filter now. So low pass to low pass transformation, I already said you, in place of s, if you put s by omega c, you will get your analog low pass filter from normalized low pass filter. So I've just did s by 10 in place of s and I've found it. Next we have HP with omega u and omega c's. Omega u is nothing but upper cutoff frequency, that is nothing but omega c. Now low pass to high pass I'm doing. For that, the transformation is s is equals to omega c by s. Here it was omega s by omega c, here it is omega c by s. When you substitute it, you will convert and you will get the answer. Same with your band pass filter. Here they have given as bandwidth is 10. Bandwidth is 10 in the sense B0 is 10, that is given. B0 is nothing but omega u minus omega l, that is upper cutoff frequency minus lower cutoff frequency. So we'll use that here. We have one more formula, that is omega naught, that is nothing but center frequency. Omega naught equal to root of omega u omega l. Here in this equation, when we substitute, what will happen is the above equation will have s square plus omega u into omega l by s into omega u minus omega l. Okay, so when you this s square, write it as it is. Omega u omega l, you already know from this formula, that is omega naught square. Omega u minus omega l is b naught. You have been given all these values, you substitute and you find the values. That's it. Then for band stop also, you have a formula, that is in place of s, you have to substitute this long thing. Where you have to substitute this, you have to substitute in this equation, in this place of s. Here also, this s, this part is there, no? This should be substituted here. All those values will be given, you can directly substitute and find the answer. This is one more type of question. And next type of numerical in Butterworth is, okay, next type of numerical in Butterworth will be, they will give you high pass filter specifications. According to the specifications, you have to design a high pass filter using low pass filter. Basically, the third type is high pass filter specifications will be given. You have to find analog high pass filter using normalized low pass filter. Okay, so here they've given us maximum cutoff, that is kp is given, omega p, ks and omega s. Here what you have to basically do is, first here there's a trick. I said you have to use normalized low pass filter for any filter designing. So when we use normalized low pass filter, our omega p will always be equal to 1 radian per second. 1 radian per second. So here we have been given that is 200 radian per second, which should be converted into 1 radian per second. So when I take this as 1 radian per second, here I'll have confusion what to take this. So using backward calculation, omega s is equals to omega u by omega s dash. Omega u is already given, that is 200, and omega s dash is 100. So here 2 radian per second should be substituted. After writing this diagram, you can like the first sum which I had explained, find n, then you'll get h n of s, then you substitute s by omega c, then you'll get h a of s. So this is the process to do the next sum. Thanks for watching. Don't forget to subscribe and share it to your friends so that it will be helpful for them also.